So at the beginning of the class, we saw a GIF working on coloring a graph in real time. So here, I'm running the same algorithm on my computer design, and in this case, I'm drawing the graphs by using my mouse. All right, as you can see, I can draw and solve a planar graph in real time very easily using the algorithm. But it's worth noting that it's here we are only having straight lines as the boundaries, so the maximum it can have is 4 colors. Okay, so if we go to the generation file, this is part of the code of our algorithm. So basically, it consists of three parts. The first part is the graph generation, where we generate a more complicated graph than which we've seen before. So in this code, we're generating basically graphs using a batch script. All right. So here we can define the number of vertices and the number of edges we want to have for the graph. It can be any number up to 90% of n squared. The edge number can go up to that, and the vertices number can be any number. But in our testing, if the vertex number go up to more than 100,000, it's gonna eat up our memory space, and it's gonna be too much. Okay, and in this one, as you can see in the planar graph, the website we're using also generates a edge and vertices pair, right? So the first line is the number of the vertices in the graph, and the line after it specifies the edges. So all the edges are bidirectional, so it doesn't matter which number comes first, but some of them it's the same. All right. So if you can look at this part here, we're using LDF, which is large degrees first. It's an algorithm for computing coloring, which Jianqiao and Yuxuan has been covered before. So in this part, we have a read graph and a checker, which will verify the legitimacy of our output coloring. So we'll make sure that on each edge, the source and target are of different colors. And so if we dive into an example output for our algorithm, you can see, so each line represents one vertex. As you can see from the source code. So source file. So it gives us the new color, which is basically a number, right? So if two vertices have both the number 8, that means they are color with the same color. And here we have the third part, which is also the last part for our project, which is the visualizer. So this visualizer can will help us visualize our output. So it's very different from the first one we've seen, because the first one is just a simple straight line planar graph, but this one is actually very more complicated. So you can see that right here right now. Basically, I use random colors to put up with for each cluster I put the vertices into. So every time I move my mouse onto one cluster, it will highlight its neighbors. So here I'm trying to drag out one vertices and all its neighbors and show you that they are all of different colors. It's kind of hard. Why don't we just drag all the vertices of the same color to one place? I think that should be a lot easier. Yeah. So let's drag all of them to this side and all the rest to the other side. Okay. No, there is just too much to do. Okay, so I think there are 1,000 vertices here. I won't be finishing them in time. But as you can see, every part I'm highlighted, they are of a different. It has a different color with its neighbor. So at the end, we'll have several independent sets at the end of our algorithm. Okay, so let's just done with that. You can see the highlighting here and the stuff and the coloring here. So these are the two inputs I took from the algorithm. That's basically what we have here. This is the visualization and the code generation works. I'm just here to give you some insight, and this is part where I wrote my the visualization code. As you can see, it has some sample input. I can either use a GEXF file or I can use a TXT file which I specify. So I add a new TXT parser and a color parser here. Yeah, that's basically it. Okay, thanks for watching.